All right, so I thought we'd look at the 2024 Northern Hemisphere Methods Exam 1 paper, see how we go. So first question on exam 1, very common, differentiate something. So y equals x e to the x squared plus 1, find and factorize dy dx. Okay, we're going to have to use the product rule. The first function is u, which is x. Therefore, u dash is just 1. V is e to the x squared plus 1. V dash is, okay, this is where you need to apply a chain rule inside this first part. So you need to differentiate this and bring that, and so differentiate the sort of inner function, which is this top part. So that will give you 2x. And then you leave the e to the x squared plus 1 up there. Okay, then the product rule says you take u v dash plus v u dash. So our final answer to dy dx will be x squared plus 1, because that's 1 times x squared plus 1 plus 2x squared e to the x squared plus 1. Okay, and you can see why it says factorize. It looks like to me I've made an error there. This first part should have been e to the x squared plus 1. I think you would agree. Okay, and then so that's a factor. So that comes out the front, e to the x squared plus 1 out the front of 1 plus 2x squared. And I think that would be the right answer there. Okay, the next one is let f of x equal x cubed divided by log e of x. Evaluate f dash of x at x equals e. Okay, so this looks like a quotient rule. So again, u equals x cubed. U dash equals 3x squared. We take the derivative of that. V equals log base e of x. Okay, v dash is the derivative of that. Now, the derivative of log e of x is 1 on x. Okay, the product rule, for those who may have forgotten, is dy dx of the quotient of two functions is v u dash minus u v dash divided by v squared. So now if we apply that to here, we're going to get dy dx equals vu dash. So 3x squared log ex minus uv dash. So uv dash would be x cubed times 1 on x, which is just x squared, all divided by v squared. V is log e of x all squared. So we're going to get log base e of x all squared. And then we need to evaluate that at x equals e. So we're going to get, okay, let's think. Let's do this because I'm running out of space. So this would be 3e squared. Log e of e is 1. So the first part's 3e squared minus 1. And the bottom part is 1. So our answer is 3e squared minus 1. So what we can say is f dash of e equals 3e squared minus 1 on 1, which I'm not going to write because you divide by 1, it stays the same. So the final answer is 3e squared. What am I doing? That's not right. I substituted e wherever there was an x, not 1. So this has to be, and this would have been an e, right? This would have been an e. So this would be 3e squared minus e squared, which is 2e squared, which I think is the right answer. Next question. Consider the simultaneous linear equations ax plus 2 minus a times y equals 3 and x plus ay equals 2a plus 1 on 2, where a is an element of real numbers and x and y are also real. Find the value of a for which there are infinitely many solutions. Okay, infinitely many solutions means that the gradients and the y-intercepts are the same. So what I would do is I'd take these equations and I'd rearrange them to put them in y equals mx plus c form. So we call this equation 1. So call this equation 1, and this can be 2. So if we try and do number 1 first, so we're going to get, all right, let's rearrange for y. So we're going to get 2 minus a y equals 3 minus ax. Okay, divide everything by 2 minus a. So y equals, all right, I'm going to put the a first. So it's going to be minus ax on 2 minus a plus 3 on 2 minus a, dividing everything by 2 minus a. All right, let's do the same for number 2. So let's rearrange that. So I'm going to get ay equals 2a plus 1 on 2 minus x. Okay, just do a bit of a rearrangement. So I'm going to get y, divide everything by a. So I'm going to get negative x on a. And divide this fraction by a. So it's going to be 2a plus 1 on 2a. Okay, now we know the following. To have infinitely many solutions, we know that the following must be true. We know that the gradients must be the same. So negative a on 2 minus a must equal negative 1 on a. So let's write that out. We're going to get negative a on 2 minus a is equal to negative 1 on a. Okay. Hopefully that can be solved. So let's try and solve that. Multiply a to both sides. We're going to get negative a squared and multiply 2 minus a to the other side. So it's going to be minus 2 plus a. Okay, this was a quadratic that needs to be solved. So I'm going to run out of space. So we're going to get, let's make the a squared positive. It's going to be a squared minus 2a plus a equals 0. So what's that? A squared minus a equals 0, in which case, if we factorize that, we get a minus 1 equals 0. So either a equals 0 or a equals 1. And that's not right. Where did I go wrong? Oh, where did that a come from on the 2? That's no good. Let's try that again. There was not supposed to be that there. So this becomes a squared plus a minus 2 equals 0. Factorize this. Okay, it multiplies to negative 2, adds to 1. So it's going to be a minus 1, a plus 2, a minus 1. Okay, that's factorizing that. Multiplies to negative 2, adds to positive 1. So then you get a equals negative 2 and a equals 1. Okay, now which one does it equal? We need the gradients to be the same, so that would force those to be the same. So now we need the y-intercepts to be the same. So let's do a being 1. For a equals 1, we would get that this part would be 3 on. So for a equals 1, we'd get 2 times 1 plus 1 is 3 on 2a. 2 times a would be 2, so 3 on 2. And the other one would be 3 on 2. So I reckon find the value of a, yeah, so a equals 1. Okay, obviously a is not equal to 1 because I just made a very small and silly error. So because 2 minus 1 is 1. So this one would have been 3 over 1. So that would give us Same gradients, but different y-intercepts, which means that there would be no solutions. So let's try this out. So let's try for a equals -2. If we do for a equals -2. Okay, for a equals -2, the y-intercept is going to be the first one over here, 3 divided by 2 minus a. So that's 2 minus -2. So that's 3/4. That's 3/4. That looks better. And then this one here will be, let's just do it, 2 times -2 plus 1 over 2 times -2. Okay, that's -3 over -4, which is +3/4. So our answer is a equals -2 and not negative and not +1. But we did know that for a equaling +1, that we got the same gradient. So that must mean for a unique solution, a does equal +1, and it's 1 mark. So I reckon that's right. Find a value of a such that the lines meet at right angles. Okay, that must mean if they meet at right angles, then this negative a on 2 minus a, which is one of the gradients, has to equal the negative reciprocal of this. Because remember, when lines are perpendicular, when the gradients have negative reciprocals of one another. So the negative reciprocal of -1 on a is a. So when that equals a. So try and solve this now. What are we going to get? We're going to get -a equals 2a minus a squared. Okay, and then let's try and solve this. We're going to get a squared minus 2a minus a equals 0. So what's that? A squared, maybe I got it right this time, minus 3a equals 0. So you get a times a minus 3 equals 0. So either a equals 0 or a equals 3. Okay, we need to reject a equaling 0. Because if a equals 0, things don't work. Basically, your line is no longer a linear line. Because if this is 0, then you've got a problem. Similarly, if this is 0, you've got a problem. So reject that answer and say that a equals 3 is when the lines meet at right angles. Good stuff. 2 down. All right, let f be a function on the domain D, where f of x equals 3 log e of 2 minus x, where D is the domain for f. Yep. State the maximal domain for f of x. Okay, what could be good here is to just do a little rearrangement. 3 log base e, because we're used to seeing it in this form, right? Take out -1 as a factor, and then you'll be left with x minus 2. Okay, and then I think a little sketch here will help. We've got a vertical asymptote at -2, +2. It's been shifted to the right. It's got an asymptote there. So does our graph look like this? State the domain for x. But it's been reflected in the y-axis. So it looks like that, maybe. So -∞ to 2. I think that looks good. Okay, sketch the graph of y equals f of x, labeling the asymptotes with this equation, the axial intercepts with their coordinates. So ... That's pretty good. X equals 2. Okay, axial intercepts. So to find the y-intercept, let x equals 0. So let's do that. F of 0 equals 3 log base e 2 minus 0, which is just 3 log e of 2, which is just a number, but that is our y-intercept. So that's going to be here somewhere. I don't really care where it is. There's no numbers on the axes. And x-intercept with y equals 0. So 0 equals 3 log e 2 minus x. So 0 equals log e of 2 minus x divided by 3. All right, e to the 0 is 1. Raise both sides to the power of e. So you get 1 equals 2 minus x. 2 minus what equals 1? 1. So there must be an intercept here. So I reckon the graph looks like, and I'm going to butcher this drawing. I reckon it looks like that, and this is at 1, 0. And this is at 0, 3 log e of 2. I think that looks pretty good. All right, I'm going to try and squeeze question C in here. It says find the values of x for which f of x is between 0 and 3. Okay, so we need the y values of this function. So essentially sort of the range to be between 0 and 3. So 0 is down here, obviously. 3. Well, 1's there. Oh, no, it's not. 3 log e of 2 is there. So I don't know, 3 might be there somewhere. So, this is y equals 3. This is y equals 0. Well, f of x equals 0 and f of x equals 3. Okay, and so what we kind of need to know is we know that the maximum x value we can have is 1. So let's think about what the minimum is. We need to set the function. So 3 log e 2 minus x equal to 3, because we want to know when the whole thing equals 3. So we're going to get log e of 2 minus x equals 1, divide everything by 3, and then we're going to get 2 minus x equals, all right, raise both sides to the power of e, or e to the power of both sides. So we're going to get e. So then we get, subtract 2 and divide by -1. So you're going to get, we're going to run out of space is what's going to happen. So we're going to say negative x equals e minus 2. So x equals, squeezing this in, 2 minus e. Yes, 2 minus e. Okay, so I reckon the values of x for which that's true is, all right, we need to have x between 2 minus e. Remember, that's going to be slightly negative, right? E is approximately 2.7. So I reckon the answer is 2 minus e less than or equal to x, or x is greater than or equal to 2 minus e, but less than or equal to 1. And so that would give us the function between 0 and 3, because there's some point, wherever this is, this x value here is 2 minus e, and it gives us a y value of 3. All right, question 4. Let g be a function between 3 on 2 and infinity, and g of x is log e of 2x minus 3, and h is a domain of all real numbers, and it's e to the 3x plus 2. Show that g of h is defined for x an element of all real numbers. So this one here, let's think. Remember, for a composite function to exist, the range of the inner function, let's write this, the range of the inner function in this case is h, must be a subset of, that was too strict there, curlier, the subset of the domain of the outer function. The outer function in this case is g. So let's think about what the range of h is. The range of h would be, let's do a quick sketch, e to the 3x plus 2. It's been shifted up to, and e looks like that. So I reckon the range of h is 2, not including, to infinity. And we need to make sure that's a subset of the domain of g. Well, the domain of g is 3 on 2 to infinity. What have I done wrong there? Let's have a think. Yeah, let's just retry that. So what do we got? So sometimes, I think I stuffed up which one was the inner function, g of h of x. Okay, so the output of h of x. Oh no, maybe I was right. The range of h has to be a subset of the domain of g. Yeah, that checks out. Yeah, yeah, I was right. All good. So yeah, the range of h is 2 to infinity, and that is within 1.5 to infinity. That sits inside 3 on 2 to infinity. I don't know why I always struggle with those ones. This thing has to be smaller. So that 3 on, sorry, this thing has to be bigger. Yeah, sorry. This thing is the bigger thing. So 2 to infinity sits entirely within 1.5 to infinity. If you're ever stuck, like me, clearly, just draw a number line. So, 3 on 2 is here. 2 is here. 3 on 2 to infinity would be this subset, and 2 to infinity is that subset. So this top line fits entirely within the other line. So we can say, therefore, that it's defined for all real numbers. Yes. Okay, I think that checks out. Find the range of g of h given the domain of g of h. Oh, yeah, okay. All right. So there's more to this previous question, I think. So what we could also say is that, remember, the domain of the composite function is the domain of the inner function. Function equals the domain of the inner function, which is h. And the domain of the inner function, h, is all real numbers. So, yes. Show that it is defined. Well, yes, it is defined. Because because the range of h is a subset of the domain of g, and the domain of the inner function is all real numbers. Find the range of g of h given the domain of g of h is all real numbers. Find the range of g of h. All right, what I would recommend is here we've got to work out what g of h is. So I prefer this notation, g of h of x. Okay, so we're going to take g, and wherever there's an x, we're going to put h of x. So I'm going to take log base e of 2x. All right, wherever there's an x, I'm going to put this e to the 3x plus 2 minus 3. Okay, let's make a few simplifications. Log base e. Okay, what's that? 2e to the 3x. Okay, that'll be 4 minus 3, so that's going to be plus 1. Okay, now we know that all of that has to be greater than 0. Okay. Okay. All of this has to be greater than 0, but we also know we could also just work out the smallest value that this could possibly be. So let's think about what this inner function looks like. The inner function would have a minimum value of 1. So it's going to look like this, something like that. And so the smallest this can get is 1. And log e of 1, or a number close to 1, is 0. So the smallest output, we're looking for range values of this function, is 0. So I reckon the range of g of h of x equals 0. Okay, is there any limit to this? Well, this gets really large. If I take log e values of some number that gets infinitely large, that will also approach infinity. So I reckon the answer is 0 to infinity. And I'm sure that's right. I think that's right. All right, this one I'm a bit sketchy on. So if you think I get this wrong, let me know. So in a nursery, 90% of seeds will grow into seedlings. Let p hat be the random variable representing the sample proportion of seeds that will grow into seedlings for samples of size 100. Find the mean and standard deviation of p hat. Now, I think that this one is just on the formula sheet, which is n times p. So the expected value, how many of these seedlings would you expect, which is kind of like the mean, right? Would you expect to grow into seedlings from a sample size of 100, where you'd expect 90%, so you get 0.9 multiplied by 100. which would be 90. But this is not my strongest topic, so keen to know if any of that might be wrong. So the other thing is the standard deviation of p hat of the sample proportion, and this is on the formula sheet. Basically, I think you take the sample proportion and then you multiply by 1 minus p hat all over n, which is the number of trials you're doing. I could have got that notation wrong. Let me just double check actually, because might as well do it properly. Okay, this first one was wrong, and yeah, I can see why. So we're sampling, right? So we've got 100, whatever it is, seeds, and we're saying, all right, what is the sample proportion mean? And that's just equal to 0.9 in this case. So 90% of seeds will grow into seedlings. So the sample proportion will be 0.9. And I just got this symbol wrong here. So this would be P times 1 minus P all over N. So the standard deviation for the sample proportion is given by 0.9 times 1 minus 0.9. Well, that's 0.1 divided by 100. Okay, and this is calc free, right? So you need to be able to work this out. So this is 0.09. Is that right? 0.09 divided by 100. So it's the square root of, if you take the square root of 0.09, you get 0.03 on 10, which is 3. And just do a sanity check. Let me think. Okay, so clearly I can't work with fractions because that did not make any sense. That was nonsense. Let's redo this. Okay, let's do it properly. So what can be difficult, as I just showed, to take the square root of 0.09. Is it like 0.03? Is it 0.3? Is it 3? So what we can do is, as long as we keep the ratio the same, so if I multiply the top and bottom, so if I put this 9 on and move the decimal place, so this can be 1, 2. So we're going to need another 2 zeros. So 1, 0, 0. Okay, so what's that? So what's the square root of a 10,000? 100 times 100? Yeah, so this is 3 on 100. So that's 0.03, and that makes a lot more sense because we're talking about the sample proportion. So we would expect in the sample to have a mean of 0.9 because 90% of the seeds grow into seedlings. And from that 0.9, we'd have a standard deviation of 0.03. So we're going up to 0.93 and down to 0.87. Okay, for one standard deviation, that seems to make more sense. All right, this one I'm very sketchy on. Let Z be the standard normal variable such that Z is normally distributed with a mean of 0 and a standard deviation of 1. And the probability that it's greater than that the standard normal random variable is greater than -1 is 0.84. Using a normal approximation of p hat, estimate the probability that in a sample of 100, more than 93 seeds will grow into seedlings. Give your answer correct at 2 decimal places. All right. I am not confident with this one, so let me know what you think. What I like with a standard normal is to draw a bell curve. So this is at 0, then this is at 1, then this is at -1. Okay, it says that, so this represents the mean. This represents one standard deviation below the mean. So this area here must be 0.84 because there's a 0.84% chance that it's greater than one standard deviation below the mean. Using the normal probability in more than 93 seeds will grow into seedlings. So, if we think about what else, if we make sort of the transformation, the mean would be 90 93 would be here. 87 would be here. So what we want is, we want it to be greater than 93. So that would be this area here, greater than 93, just this part. But we know that this total part is 0.84. So this part here must be symmetrical to this part. And since, this part was 0.84, this part must be 0.16. So that's my answer. But I feel like I didn't do enough calculations there. So I'm going to say that the probability that p hat, a sample of 100 more than 93 seeds. That p is a random variable in the sample proportion. I'm a bit sketchy on how to do the notation. Let me think. Okay, I think so. A few things, because the sample proportion is given by this. It's wrong. P hat is equal to x over n. So really what we're representing when we say more than 93 is we're saying x needs to be greater than 93. So I think the answer, that's how I might notate it. And I reckon the answer is 0.16. But I'm happy to be corrected on that one. All right, part of the graph of g of x equals sine 2x minus 5 pi on 6 plus 2 is shown below. Use trapezium rule of with three trapeziums of equal width. Estimate the area bounded by the graph of y equals g of x, the x-axis, and the lines x equals pi on 6 and x equals 2 pi on 3. I made a whole video about this, so rather than answering part A here, I will send you, I'll put the link below the video so you can go and watch that if you're interested in the answer to that. I answer it much more nicely than I could with the pen and paper here. But we can do this. So let H, again, let H be some function which is equal to K times G of X. So G of X is the previous function. Use calculus to find K such that H is a probability density function. Okay, so what we need to do is, if the probability density function means the area under the curve is 1, so we're going to take K times the integral, okay, from pi on 6, pi on 6 to 2 pi on 3. Okay, of sine, I'm going to write out the function, right? The function is sine of 2x minus 5 pi on 6. Plus 2 dx. And we need that to equal 1, right? Because it's a probability density function. Now, this is where, again, this is non-calc, so you need to be very careful. You need to take the integral of sine 2x minus 5 pi on 6. Now, this will be on your formula sheet, but basically it's negative a half cosine of 2x minus 5 pi on 6 plus 2x between pi on 6 and 2 pi on 3. Okay, and that's all multiplied by k, and all of that equals 1. Okay, sub in everything. So you're going to get 1 equals, let's put 1 on that side, and I'm cheating here because I've done it before, but I'm going to get negative a half cosine Okay, subbing in 2 pi on 3, so you're going to get 4 pi on 3 minus 5 pi on 6 plus 4 pi on 3 again. Okay, that's just the first part, right? Minus the second part, which is negative a half cosine. All right, 2 times pi on 6 minus 5 pi on 6. Um, ah, brackets in the right spot, minus 5 pi on 6. Um, 1, 2, 3, 4. Yes, that looks good. And then I got a plus pi on plus 2 times pi on 6, which is pi on 3, right? So good luck doing this under time conditions. That's why you got to practice. So you're going to get, and all of that's multiplied by k, don't forget. Okay, this simplifies to 1 equals, all right, negative a half. I'm showing maybe more steps than you might need. Negative a half cosine of pi on 2 plus 4 pi on 3 minus negative a half cosine of negative pi on 2, apparently. Cosine of negative pi on 2 plus pi on 3. Okay, so all of this, you need to get a pen and paper out and work it all out, but it's 4 pi on 3 minus pi on 3, apparently, multiplied by k. And so you get 4 pi on 3 minus pi on 3 is 3 pi on 3. So you get the following. You get pi k equals 1. So k equals 1 on pi. I thought that question was pretty brutal, but it's not actually, it's doable. You just got to be very careful with how you go about things and all the substitutions you make. Okay, hopefully that's correct. Maybe I'll just add before I move on that this actually simplifies nicely. I just sort of didn't explain it because I was looking at the solution, or my solution. That goes to 0 because cosine of pi on 2 is 0. Cosine of negative pi on 2 is 0. So that whole those terms disappear, and you're just left with 4 pi on 3 minus pi on 3, which is which is pi. Okay, let x be a discrete random variable with a probability mass function of probability x equaling x is 2 on 3 to the x. Okay, nice, easy 1 mark question here where z is a positive integer. Okay, so the probability x equals 4. Hopefully this is an easy mark. It's just going to be 2 on 3 to the 4. And can we work out 3 to the 4? 3, 9, 27, 81. So what's that? 2 on 81. Okay, find the probability x is less than 4 given that x is greater than or equal to 2. So let's work this out. The probability x is less than 4 given that x is greater than or equal to 2 is going to be equal to the probability of x less than 4 and x greater than or equal to 2, all divided by, terrible vinculum, divided by the probability of x being greater than or equal to 2. Okay, let's think about this numerator because this might simplify. What's the probability it's less than 4 and greater than or equal to 2? So I like to draw a number line sometimes. So, 1, 2, 3, 4 is there? All right, it has to be less than 4 and greater than or equal to 2. So the only part where they overlap is 2, 3, and 4. Greater than or equal to 2, less than 4. Okay, not including 4, not including 4. So really, since it's discrete, it's essentially, if it's a discrete random variable, then it's just 3 and below, right? So the only place they overlap is actually at 2 and 3. So this is the probability x equals 2 plus the probability x equals 3 on the numerator divided by the probability x is greater than or equal to 2. Okay. Probability x is greater than or equal to 2. We don't know how high this goes up. Doesn't tell us. So greater than or equal to 2 is just 1 minus the probability x equals 1. Hopefully that makes sense. I don't know how else to explain it. Probability x equals 1. Okay, so let's work this out. The probability x equaling 2. Okay, so we're going to get a big old fraction here. So it's going to be 2/9. So we're subbing in, we're going to use this, and we're going to sub in x equaling 2. So it's going to be 2 over 3 squared, which is 2 over 9, plus probability x equals 3. So that's 2 over 27. All divided by x greater than or equal to 2, which is 1 minus the probability x equals 1. Probability x equals 1 is 2 over 3 to the 1. So that's 2 over 3. So I reckon that's the right answer. So we're going to get, okay, let's get common denominators. Multiply this by 3. So I'm going to get 6 plus 2. I'm going to get 8 on 27 divided by 1/3. So that's 8 on 27 multiplied by 3 on 1, which is 24 on 27. Can that be simplified? Oh, it can actually. 3 goes into both of those. 3 goes into 24 8 times, and it goes, so 8/9. I think that's right. Fingers crossed. All right, f is a function from -1/3 to infinity, 1 on the square root of 3x plus 1. Find an antiderivative of that. All right, so we need to take an integral. The integral from an antiderivative, so we can take the indefinite integral, yeah? So it's going to be 3x plus 1 to the -1/2 dx. Okay, and then this is, yeah, this is just the power rule, I think. Let me think about that for a second. Yes, very good. I always forget that when you've got the integral of ax plus b, that's on the formula sheet. So what you get is this. So it's 3 multiplied by -1/2 plus 1 multiplied by 3x plus 1. This stays the same. Okay, you raise the power to +1/2. Then you add c. All right, let's work out this. So it's -3 on 2 plus 1. What's that? -1. So this just becomes 2/3. Pause the video, have a think about why that's the case. 3x plus 1 to the 1/2. Don't forget the plus c. People will lose marks if they don't have the plus c, I think. Find an antiderivative. Yeah, anyway, put the plus c to be safe. Okay, let's do the next one. Okay, this is something that isn't on the formula sheet, so you need to know the average value of a function. The average value of a function is 1 over b minus a. Maybe I'll write it. It might help. 1 over b minus a. Yeah, the integral from a to b, f of x dx. So if we just read the question again, the average value of the function f over 0 to m is 1/3. Find the value of m. Okay, so the integral from 0 to m of f of x is 1 on 3x plus 1 dx, and we know that it's an integral, so it's 1 over, we have to do 1 over b minus a, so it's 1 on m out the front, and we know all of that equals 1/3. All right, we know the answer to this though. We know that, we just worked that out, right? We know that that's 2/3 3x plus 1 to the 1/2 between 0 and some point m. And that equals, okay, I'm going to say this all equals 1/3 at the end, just so I can do another line of working out. So there's 1 on m. Okay, sub in m. So you're going to get 2/3, 3 times m plus 1 to the 1/2. Put that there, and then that's sub in minus Oh, what's this? This is going to be 2/3, 3 times 0 plus 1 to the 1/2. And all of that equals 1/3. Okay, this is getting a bit tricky. So let's see. This is 1 on m multiplied by 2/3. This doesn't really change. 3m plus 1 to the 1/2. Okay, hopefully this goes away. So this is just 1 to the power of a half is just 1. 2/3 times 1 is minus 2/3. That equals 1/3. Okay, I need more space. All right, let's keep going. So, all right, we could multiply this 1 on m, multiply. So let me explain. So 2/3, 3m plus 1 to the 1/2 minus 2/3 equals, multiply that. I'm going to get m on 3 on the other side. Let's just drop this equal sign here. It's a bit dodgy, but okay, then we can keep going. So what would we get? I think we're going to get a quadratic. Let's think. So we're going to get 2 times the square root of 3m plus 1 on 3 minus 2/3 equals m on 3. Okay, this is going to give us 2 times the square root of 3m plus 1 all over 3 equals, all right, add 2/3 to both sides. I'm going to m plus 2 on 3 on the right-hand side. Okay, cross multiply. Let me get more space again. Okay, multiply 3 to that side, multiply 3 to that side, or just cancel the 3's out. So you got 2 root 3m plus 1 equals m plus 2. So you're going to get, all right, then we can do 3m plus 1, all right, equals m plus 2. So it's going to be, all right, I'm going to divide both sides by 2, and then I'm going to square both sides. So I'm actually going to get a quadratic. I'm going to get m squared plus 4m plus 4 all over 4. And we're almost there. Hopefully I can squeeze it in this time. So we're going to get 12m plus 4 equals m squared plus 4m plus 4. Okay, make it a quadratic and solve it. So you're going to get m squared, all right, minus 8m equals 0. m minus 8 equals 0. So m equals 0 using the null factor law, or m equals 8. And m does not equal 0. Why not? I don't think m equals 0 because if we go back up to the top, yeah, m is not 0 because it says in the question here, and I know it's a bit, all this stuff's in the way, but m is greater than or equal to x, and x is greater than or equal to 0. So I think we're safe to say that m cannot equal 0. Okay. All right, this one says, let f be from 0 to infinity, f of x equals x minus 1 e to the negative x. Find f dash of x. All right, you got the product of two functions again. So question 9, that's going to be harder than the first one. U dash equals 1, v equals e to the negative x, v dash, therefore, equals negative e to the negative x. Product rule, multiply this by this, and then add this times this. So you're going to get x times 1, x minus 1. If I take the negative from here, I'm going to be e to the negative x plus e to the negative x. And what will be left with? We might be able to take a factor out there. So if we take e to the negative x out as a factor, we're going to be left with negative x minus 1 plus 1. So this, I think, becomes e to the negative x. Negative x plus 2. Did I miss anything? Yes, I did. Is it supposed to be negative there still? Took e to the negative x out. Negative x minus 1. No, give me 1 second. No, it was all good. It was correct. E to the negative x, 2 minus x, if is probably a nicer way to write it. I think that's the derivative. Okay, state a sequence of transformations that will map the function onto its derivative. Now, I actually think this is the hardest question in the paper. So I'm going to go over to Desmos and explain for you. Okay, so we've got f of x equals x minus 1, e to the negative x. That's the red function, which you can see here. All right, we need to map the red function onto the blue function. So f dash of x is the blue function. It is whatever it is, or it's what we worked it out to be, actually. Okay, what transformations could we apply to f of x to get it to be f dash of x? And after much trying to work this out, if we reflect it in the x-axis, I think you can see it needs to be flipped. So that would mean negative f of x. You can sort of see this green line now. We're trying to get that green line on there, and then reflect it, translate it one to the right. So if we put that in there, translate it one to the right. And now, and I have no idea how you're supposed to do this in an exam one, it's beyond me, but it's a dilation by 1 on E. And let me show you. I think it'd be better if I use a slider. So at the moment, we've got this green line. It's almost at the blue line. If we dilate it by a certain amount, it's going to, at some point there, you can see, be on top of the blue line. Now, I honestly have no idea how you're supposed to work this out. I don't know how to do it algebraically. I'm sure there's a way. That's why I'm not bothering to write it down. But the answer is 1 on E. So I think the three transformations are a dilation by 1 on E from the x-axis, a reflection in the x-axis, and a translation 1 unit to the right. So, yep, I reckon that's quite tricky. I should also point out that that's probably not the only way you can do it. There's probably other transformations that would be a correct answer to that question. So that's just the one that I was able to come up with. All right, show that d dx of negative x e to the negative x equals f of x. So again, to me, this is just a product rule question. U equals negative x, u dash equals negative 1, v equals e to the negative x, v dash equals negative e to the negative x. Okay, product rule, this times this plus that times that. So it's negative xe to the negative x. So we could say that, yeah, no, let me write it out. d dx of negative xe to the negative x equals, all right, this times this. So that's xe to the negative x minus e to the negative x. And if we take e to the negative x out as a factor, we're left with x minus 1, which equals f of x. You would agree. F of x is up here, x minus 1, e to the negative x. So, looks pretty good. So, QED as required, or whatever it means. All right, last question. Let g of x be the tangent to y equals f of x at the point 3, f of 3, using the fact that the derivative of negative xe to the negative x equals f of x, or otherwise determine the area of the region bounded by the lines x equals 1, y equals g of x, and the graph y equals f of x. All right, this is going to be challenging. It's 4 marks. It's the last question. So what we need to do is say the following. I'm going to really struggle to squeeze this in. It's going to be the integral from 1 to 3 of g of x, because that's the upper function, right? We're trying to find this area. G of x. I don't even know what that is yet, I don't think. Okay, g of x minus f of x dx. Essentially, that's what we're trying to solve, right? It's the integral from 1 to 3, right? So it's the integral from 1 to there. Okay, what we're going to need to know first is what is the equation of g of x. I'm going to try and squeeze that in over here. So it says that g of x is a tangent to f of x at the point 3, f of 3. So what would be good to know is what is the derivative of f of x. Now, have we worked that out already? We worked that out on the previous question. So if you go back, you'll get e to the negative x, 2 minus x. E to the negative x, 2 minus x. Okay, and we said that we want to evaluate that. It says that it's a tangent at the point 3, so we want to know f dash of 3 because we need to come up with the linear line, right? It's e to the negative x, which is x is now 3. E to the negative 3 times 2 minus 3 is negative 1. So we're going to get negative e to the negative 3. Okay, and then what we can do is we know that that's the gradient of g of x. So we can say that this is, and hopefully you would agree, this is negative 1 on e cubed x plus c. Has to take on a linear line, right? Has to be a linear line. Okay, now we also know that the y value goes through at f of 3. So let's evaluate f of 3. Let's work out what this point is. This point is at 3, f of 3, or f from the previous question, again, is x minus 1 e to the negative x. Let's just remind ourselves of that. X minus 1 e to the negative x. So this point here, if we sub in 3, we're going to get 3 minus 1 is 2e to the negative 3. So when y is 2e to the negative 3, we're trying to work out c here, right? So this is negative 1 on e cubed multiplied by x. Well, x is 3 at that point, plus c. So after all this, we're not even anywhere near the answer. So what we can say is c is equal to, all right, 2 on e cubed is the left-hand side. Okay, I'm going to add 3 on e cubed. So I'm going to get 5 on e cubed. Okay, so now we know what g of x is, and maybe we'll write that up here as it's our conclusion. I don't have any more space. So g of x is the linear line, negative 1 on e cubed x plus 5 on e cubed. Okay, so it's the integral from 1 to 3 of that thing, which is g of x, negative 1 on e cubed x plus 5 on e cubed minus f of x. Now, f of x is this, right? And we might have to expand that out. So we're going to have to expand that out. Let's leave it for now. X minus 1 e to the negative x dx. Okay, now we need to anti-differentiate that. So let's try that. Okay, this x becomes x squared on 2. Oh, so it's going to be negative x on 2e cubed. So negative x squared on 2e cubed plus, and this term here is going to get its own x. It's going to be 5 on e cubed x. Okay, and we're just going to separate these integrals. Well, that's how I did it the first time. Okay, minus, all right, thankfully we know this. We know that the antiderivative of f of x is negative x e to the negative x because, the derivative of this thing is f of x. So if you go this way, an antiderivative of f of x must be negative x e to the negative x between 3 and 1. Okay, now you just need to crunch the numbers. Sub in 3. So you just got to do this very carefully. So it's going to be negative 3 squared on 2e cubed plus 5 on e cubed by 3. Right, that's just the first part, minus. Nah, that first part's wrong. Negatives at the front, negative 3 squared, big difference. Okay, minus, sub in 1, negative 1 on 2e cubed plus 5 on e cubed. Okay, let's do this next part. Let's see if we can squeeze it in. Minus, all right, sub in 3. So it's going to be -3e to the -3 minus, put it in brackets, minus, okay, this needs to be in brackets, negative e to the -1. Okay, then you've got to evaluate all this. So you're going to get the following. -9 on 2e cubed plus 15 on e cubed minus -1 on 2e cubed plus 5 on e cubed Am I just writing the same thing pretty much? Yeah, let's speed this up a little bit. Okay, so can't really speed it up. So it's going to be -9 on 2e cubed plus 15 on e cubed minus -1 -1 on 2e cubed plus 5 on e cubed minus, that's all square bracket, -3 on e cubed plus 1 on e. Okay, look for any like terms. There's a 2e cubed there, so it's -9. That's negative. So what I'm getting at is this term and this term. So it's a -9. So I'm going to get -8. So look for any like terms and simplify. So I'm going to get -8 on 2e cubed. All right, 15 on e cubed minus 5 plus 10 on e cubed. Okay, minus, all right, -3 on e cubed plus 1 on e. Okay, like terms again, 10 minus, so 10 plus 3 is 13. So I'm going to get 13 on e cubed minus 8 on 2e cubed plus 1 on e. Okay, yep. 13 on e cubed. So that's a 4. So 13 minus 4 is 9. Equals 9 on e cubed plus 1 on e. I've got a minus, should be -1 on e. Yeah, it should be -1 on e because -1 on e. -1 on e because that minus got expanded in. It got expanded in there. So that is the area between here and here. Maybe I'm missing something. Maybe there's a simplification you can do. I don't know. I must have missed it, but you expect the last question to be challenging, but yeah, you just got to be so careful. I feel like the concept's not that difficult. It's just, can you do the maths in the time that you're given? And having said that, I'm curious to see how long this video was. So good luck.